Welcome to today's video on part 3 of Unit 9. We're going to be solving trigonometric equations. First of all, the first page of your notes packet I would read. It just outlines the process for solving trigonometric equations, where you can substitute with a Pythagorean identity. Like, for example, here I replaced cosine squared with 1 minus sine squared, and then solve the equation. And notice, because it's a plus or minus here, that means it's in all 4 quadrants, meaning it can be in the first, second, or third quadrant, or fourth quadrant. So that's why it's all the pi over 4 angles. And then I just kept going past 2 pi, because it says find all possible solutions. And then there will be a pattern. The pattern is that it's pi over 4 plus pi over 2 times k, where k is an integer. And then if you're trying to find it between negative pi and 3 pi, you can put negative 1 in for k and solve and get negative 3 pi over 4. You put negative 2 in for k and you get negative 3 pi over 4. Put negative 1 in for k, get negative pi over 4, 0, you get pi over 4, and so on until you get all the solutions that are between negative pi and 3 pi. Likewise, for this next one, cosine 5x plus 10 equals negative rad 3 over 2. You can do the same thing where you say 5x plus 10 is equal to, the reference angle is 30 degrees because the cosine is equal to rad 3 over 2 at 30, but because it's negative, you know it has to be in quadrants 2 and 3, so it's going to equal 150, 210, and then you can just keep adding 360. Your equations for that are 150 degrees plus 360k, or 210 plus 360k, because those are the two that are between 0 and 360. And then you just subtract 10 and divide by 5, and you get all the answers between 0 and 360. And that gives you your equation as well. So let's do a few examples. One of the things to keep in mind is you talked about last year that because the coefficient is 5, there are 10 answers between 0 and 360. That is always true, that there's going to be twice as many answers as the coefficient on x. So keep that in mind as you're doing these problems. All right, so the first one, number 1 here, we'll look to substitute in, so we can make this 1 minus cosine squared minus 5 halves cosine plus 1 half equals 0. So we make it negative cosine squared minus 5 halves cosine. 1 plus 1 half is 3 halves. And then you multiply by negative 2 to get rid of the negative and the fraction. So you get 2 cosine squared x plus 5 cosine x plus 3 equals, or sorry, minus 3 equals 0. Because remember, you're multiplying by negative 2. So now you have to factor, and when you factor it, you get 2 cosine x minus 1, and cosine x plus 3 equals 0. So that means 2 cosine x minus 1 equals 0, cosine x plus 3 equals 0, cosine equals negative 3, cosine x equals 1 half, and cosine can never equal negative 3, so that doesn't work. Now it's equal to 1 half, so if you want to list the solutions, it's equal to 1 half at pi over 3 and 5 pi over 3 in the first rotation. Then if you go beyond the first rotation, add 2 pi, you get 7 pi over 3 and 11 pi over 3. And then if you look at equation form, because this is a list, equation form, it would be pi over 3 plus 2 pi k, where k is an integer, or it would be 5 pi over 3 plus 2 pi k, where k is an integer. That's for part A. For part B, finding the answers between negative pi and 5 pi, well, if you put negative 1 in here and you add, well, negative 1, so negative 2 pi plus pi over 3 would be negative 4 pi over 3, so that's too big. But here, if I put negative 1 in, I get 5 pi over 3 plus negative 4 pi over 3, so, or sorry, negative 6 pi over 3 plus 5 pi over 3, so it's equal to negative pi over 3. And then if I put 0 in here, I get pi over 3 and 5 pi over 3. And if you put 1 in and you add 2 pi, that's where you get 7 pi over 3 and 11 pi over 3. And if you keep adding 2 pi to that, well, 2 pi to 7 pi over 3, that's 13 pi over 3. That's still less than 5 pi. But if I add another 2 pi to 11 pi over 3, that's 17 pi over 3. That's too much. So for part B, there are your answers. All right, for the next one, here we simplify the equation. 4 sine 3x equals negative 2. So the sine of 3x is equal to negative 1/2. So 3x is equal to, and then negative 1/2 for the sine would be 7 pi over 6, 11 pi over 6. You add 2 pi to that, so 12 plus 7 is 19 pi over 6. 23 pi over 6. And you can keep going. You would get 31 pi over 6. And 35 pi over 6, and it would just keep going. Now, if you divide by 3, that gives you your list for part A. So if you divide by 3, you get 7 pi over 18, 11 pi over 18, 19 pi over 18, and 23 pi over 18. So there's our list. Now our equation for part A would be that x is equal to, because if you looked at the top part, 3x was equal to 7 pi over 6 plus 2 pi k, where k was in z, the integers, or it was 11 pi over 6 plus 2 pi k, where k was an integer. Now, if you divide by 3, you get 7 pi over 18 plus 2 pi over 3k, where k is in the integers. Or, if you keep going out, you get 11 pi over 18 plus 2 pi over 3k, where k is an integer. So that's part A. We'll put a little line there. So for part B, it wants to know the solutions between 0 and 2 pi. Well, you have 7 pi over 18, 11 pi over 18, 19 pi over 18, 23 pi over 18. Now, if we added another, 2 pi over 3, or if we divided 31 pi over 6 by 3, 31 pi over 18 is still between 0 and 2 pi. Now 35 divided by 3, or 35 pi over 6 divided by 3 is 35 pi over 18. That is still less than 2 pi. So there's our complete list for part B. All right, next one, same deal. We first subtract 5, so I get 5 sine 4x plus 10 degrees equals -5. Divide by 5, so you get sine 4x plus 10 equals -1. Now the sine is -1 at 270 degrees, so 4x plus 10 degrees is equal to 270 degrees. Or if you add 360, it could be 630 degrees. Or adding another 360, it could be 990 degrees, and so on. So that means 4x plus 10 degrees is equal to 270 degrees plus 360k, where k is an integer. Now, if you subtract 10, so 4x is equal to 260 degrees. It's equal to 620 degrees. It's equal to 980 degrees. So 4x is equal to 260 degrees plus 360 degrees times k, where k is an integer. And then you divide by 4 to get part A, because part A is all the solutions and the list and the equation. So you divide by 4, you get that x is equal to 65 degrees, 155 degrees, and 245 degrees. So there's your list. And then your equation, x is equal to 65 degrees plus 90 degrees times k, where k is an integer. So that's part A. Now for part B, to find all the possible solutions between 0 and 360, well, that's 65 degrees, 155 degrees, 245 degrees. So that's if k is 0, 1, and 2. Now if k is 3, that's 270 plus 65, so that's 335 degrees. That's still between 0 and 360. If it was 4, that would be too big because it's already 360 plus. So those are our answers between 0 and 360. All right, so number 4, it says sine 4x plus 3 is equal to, and then we divide by -14, so I get rad 3 over 2. So the sine is rad 3 over 2 at pi over 3, so 4x plus 3 is equal to pi over 3. It's also positive at 2 pi over 3. And then if you add 2 pi, 7 pi over 3, and then 8 pi over 3. So there's our list. So that means as an equation, 4x plus 3 is equal to pi over 3 plus 2 pi k, where k is an integer, and 4x plus 3 is equal to 2 pi over 3 plus 2 pi k. So now we simplify the equation here to get, if you subtract 3, so if you subtract 3 here, I'll just do an example, pi over 3 minus 3. So if you get a common denominator, that's pi over 3 minus 9 over 3. So it's pi minus 9 over 3. So when I make my list, basically you're just going to be subtracting 9 and have it over 3. So 4x is equal to pi minus 9 over 3. And then 2 pi minus 9 over 3. 7 pi minus 9 over 3. And 8 pi minus 9 over 3, and so on. The list just keeps going, which means when you make your equation, if you subtract 3 here, 4x is equal to pi minus 9 over 3 plus 2 pi k, where k is an integer, and 4x is equal to 2 pi minus 9 over 3 plus 2 pi k, where k is an integer. So then, if you look at part A where it says make the list, part A, divide by 4. So when you divide each one by 4, you get pi minus 9 over 12, 2 pi minus 9 over 12, 7 pi minus 9 over 12, 8 pi minus 9 over 12, and so on. Our equation, when we divide by 4, x is going to equal pi minus 9 over 12 plus, and when you divide 2 pi by 4, you get pi over 2 times k, where k is an integer. And it's also going to be 2 pi minus 9 over 12 plus pi over 2 times k, where k is an integer. So that's part A. Those are your equations. Part B, now you have to find the solutions. Now if you put 0 in for k, you get x is equal to pi minus 9 over 12 and 2 pi minus 9 over 12. Then if you put 1 in for pi over 2, you get 7 pi minus 9 over 12, 8 pi minus 9 over 12. Then if you put 2 in, if you put 2 in here and you add and get a common denominator, you get 13 pi minus 9 over 12 and 14 pi minus 9 over 12. And that still works. If you do put that in your calculator, it's still going to be between 0 and 2 pi. So you can keep going and put 3 in. So if you put 3 in, you get 19 pi minus 9 over 12 and 20 pi minus 9 over 12. And then if you put 4 in, you get 25 pi minus 9 over 12 and 26 pi minus 9 over 12. And that would be between 0 and... Now the only thing you have to go back, pi minus 9 over 12 and 2 pi, those are all going to be negative, so you can cancel those out. So actually from here all the way down to there, those are all between 0 and 2 pi. So remember, you just start by putting numbers in for k, and then you just need it to be between 0 and 2 pi. Once it gets to be bigger than 2 pi, you can stop. All right, I hope you found this video helpful, and if you have any questions, feel free to ask questions. Have a good evening.